Hello my wonderful students, you are welcome to a new lesson. Today I shall be teaching you logical reasoning, and by the end of this lesson you should be able to identify the logical operations and construct truth tables. Happy viewing! You are welcome once again to the topic logical reasoning. From definition, logical reasoning is the use of language to develop a line of argument or reasoning that convinces other people. Logic is the study of the way people reason. Let's learn more about logical reasoning. Here we have a table that displays the various logical operations, the logic operators, and their symbols. We have 5 logical operations. Number 1, conjunction. The logic operator is AND. Number 2, disjunction. The logic operator is OR. Number 3, negation. The logic operator is NOT. Number 4, implication or condition. The logic operator is if, then, or implies. Number 5 is equivalent or by condition. The logic operator is if and only if. I hope this idea is clear to you. Let's know more about logical operations. The first logical operation is conjunction. The conjunction of simple statements P and Q is true only if both P and Q are true. Otherwise, it is false. Let's see the truth table for conjunction. For two simple statements P and Q, the conjunction is as follows. True and true is true. True and false is false. False and true is false. False and false is false. The next logical operation is disjunction. The disjunction of statements P or Q is false only if both P and Q are false. Otherwise, it is true. Let's see the truth table for disjunction. For two simple statements P and Q, the disjunction is as follows. True or true is true. True or false is true. False or true is true. False or false is false. I hope this is clear. The third logical operation is negation. The negation of a statement P is always false if P is true, and always true if P is false. Let's see the truth table for negation. So for a statement P, the negation of true is false, while the negation of false is true. The fourth logical operation is implication or condition. The implication or condition of if P then Q or P implies Q is false only if P is true and Q is false. Otherwise, it is true. Let's see the truth table for implication or condition. For two simple statements P and Q, true implies true is true. True implies false is false. False implies true is true. And false implies false is true. I hope this is clear. The fifth logical operation is equivalence or bicondition. The equivalence or bicondition of P if and only if P if and only if Q is true only if both P and Q are either both true or both false. Otherwise, it is false. Let's see the truth table for equivalence or bicondition. For two simple statements P and Q, true equivalent to true is true. True equivalent to false is false. False equivalent to true is false, while false equivalent to false is true. I hope these ideas they are clear to you. Moving on, let's learn about tautology and contradiction. From definition, a tautology is a compound statement or proposition which is always true for every combination of values of its constituent statements. A tautology is always true. On the other hand, a contradiction is a compound statement or proposition which is always false for every combination of values of its constituent statements. In other words, a contradiction is always false. However, please take note that when you have a logical statement that is a combination of both true and false, that such a logical statement is called an inconsistent statement. Once again, take note, when you have a logical statement that is a combination of both true and false, such a logical statement is called an inconsistent statement. I hope this idea is clear to you. Now let's take some questions. Question 1. Construct a truth table to determine whether the following logical statement is a tautology, a contradiction, or an inconsistent statement. The logical statement is P or in bracket Q and negation P, close in a big bracket, is equivalent to P implies Q. Let's see the solution to question 1. From the solution, the truth table has 4 rows underneath the heading. Why are we having 4 rows? Because the question has 2 simple statements P and Q. To determine the number of rows that will be needed, we apply the formula 2 raised to power the number of simple statements. So for 2 simple statements in question 1, the number of rows is 2 raised to power 2, giving us 4 rows. From the solution displayed, we have a column for P, being true, true, false, false, a column for Q, being true, false, true, false, and subsequent columns for negation P, Q and negation P, P or in bracket Q and negation P, also P implies Q, and lastly the column for the entire question. Following the rules governing the various truth tables for the 5 logical operations, we have a final answer being true, false, true, false. The final answer gives a combination of both true and false values. For that reason, in question 1, the logical statement is an inconsistent statement because the final answer is a combination of both true and false. I hope question 1 is clear to you. Let's see question 2. Construct a truth table for the logical statement or proposition, which is the negation of a combined big bracket P and Q in a small bracket or R. Let's construct a truth table for this logical statement. The solution is as follows. Here is the solution to question 2. Here we have a total number of 8 rows in this truth table. Why 8 rows? From the logical statement in question 2, the simple statements are 3 simple statements, P, Q, and R. Now the number of rows that will be required is 2 raised to power the 3 simple statements. 2 raised to power 3 will give you 8 rows. 8 rows underneath the heading. Now following the solution we have a column for P, a column for Q, a column for R. These are the simple statements in the question. Then a column for P and Q. Also a column for P and Q or R. Then finally a column for the complete question, which is the negation of P and Q or R. Following the principles governing the truth tables for the various logical operations, our final answer is false, 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 true, false, true, false, true. I hope question 2 is clear to you. Let's see a third question, which reads, construct a truth table to determine whether the following logical statement is a tautology, a contradiction, or an inconsistent statement. The question before us here is P and, open a bracket, P is equivalent to Q, close the bracket, thereby closing the entire big bracket, and negation Q. Let's see the solution to question 3. Here is the truth table. From the truth table displayed, this question has 4 rows in the truth table because the question is only involving 2 simple statements, P and Q. So the number of rows required here is 2 raised to the power 2 simple statement, which is 4 rows. Here we have a column for P, for Q, for negation Q, for P equivalent to Q, for P and bracket, in bracket P is equivalent to Q, and lastly for the entire question. Following the rule governing the truth table for the various logical operations, our final answer is completely false. Our final answer is always false. For that reason, the logical statement is a contradiction. The logical statement is a contradiction because the final answer is completely false. I hope question 3 is clear to you. Let's see a fourth question, which reads, question A, construct a truth table for the logical statement or proposition, which is P is equivalent to the negation of, in bracket, negation P. Question B, what kind of compound logical statement is P is equivalent to the negation of, in bracket, negation P? Let's see the solution to question 4. Here is the truth table that is required in question 4A. In this truth table, we only have 2 rows because the question before us has only one simple statement, which is P. So the number of rows required here is 2 raised to the power 1 simple statement, which is 2 rows. Here we have a column for P, for negation P, for the negation of negation P, and finally for the entire question, which is P is equivalent to the negation of negation P. So question A, the truth table is before us. Question B, what kind of compound logical statement is here? Looking at the truth table, the final answer is completely true. The final answer is completely true. So to answer question B, the compound logical statement is a tautology because the final answer is completely true. I hope these questions, they are all clear to you. Thank you very much for going through the lesson today. I want to advise that you read your textbooks to get more information Also, don't forget to attempt your quiz and your assignment. See you again in our next class. Until then, it's bye for now. Thank you very much.